Greetings and welcome. In this section we have question 6 from the DBE 2022 past exam question. We have this question here which reads as follows. The sketch below shows the graph of f of x is equal to negative x squared minus 6x plus 7. C is the y-intercept of f. A and B are the x-intercepts of f. D with coordinates -5, K is a point on f. Calculate the coordinates of E, the turning point of f. That is 6.1. So we know that this is a quadratic function or a parabola. We are given that f of x is equal to negative x squared. So to find the coordinates of the turning point, 6.1, we are given f of x is equal to negative x squared plus, that is a negative 6x plus 7. To find the coordinates of the turning point 1, we need to find the x value. Okay, the x value first. The x value we use to find the x value we use the equation minus b over 2a, which represents the axis of symmetry for the parabola. This is the axis of symmetry. We know that the axis of symmetry of a parabola always passes through the turning point. So we use this one, and then our b is negative 6. So to find x, we're going to have x is equal to negative of negative 6 over 2 times a. Our a is negative 1, so negative 1, so which gives us x being equal to 6 over negative 3. That will be negative 2. That will be a negative 3. So our x is equal to that. That is the x value of the turning point. Now we need to find the y value of the turning point. We also use substitute this value into the original equation. So we have negative x is a negative 3 squared minus 6 times x, negative 3 plus 7. Okay, work out that one. This is a negative 9 plus 18 plus 7. So our y will be equal to, this is 25 minus 9, which is 16. So therefore, the coordinates of E, the x value is negative 3 and the y value is 16. Okay. That answers that question. 6.2, we are required to write down the value of k. Now, k is representing the y value of our function when x is 5. So what I would do, although they're asking us to write down, is to do the working here. We know our equation is y is equal to negative x squared minus 6x plus 7. So basically our y here is a k, so we're going to say our k is equal to negative. Now our x is negative 5, so we substitute negative 5 minus 6 times negative 5 plus 7. Therefore, from here we'll get the value of k, and let's enter that one. So we have a negative of negative 5 squared we will get 12. So y k is 12. Okay, so that gives us the value for k. Then it goes on to say, determine the equation of the straight line passing through C and D. That is question 6.3. We know that a straight line, the equation of a straight line, for us to find the equation of a straight line, we need two things: to find the equation of a straight line, we need A, the gradient, which is M of the line, okay, of the line, and B, we need 1 point coordinates of at least 1 point that we find on the line. So for us to find the equation here, we need at least the gradient of that line. So we assume that we have got a straight line that is running over here, C and D, and like that. So what will be the equation of that line? Now, the equation of the straight line, to find the gradient of the straight line, which is M, now we need to find the coordinates of D and C. The coordinates of D we have found already. This is -5 and -12. And the coordinate C is a y-intercept, so our x is 0 and y is 7, okay, which is the C value there. So y is 7. So we will use these two coordinates to find our gradient, which we need here. So let us do that. So we need our M gradient of CD, which is the equation y1 minus y2 over x1 minus x2. Our y1 is any coordinate, which is 12 subtract 7, okay, 12 subtract 7 over -5 subtract 0. So in this case, we are going to get 5 over -5, which is -1. So our equation, our gradient is -1. Now we can use any point on the equation, okay, any point on that straight line to determine the equation of the line. So our point, we can use C. We have C given as the y-intercept 0, 7. So we can use the equation y minus y1 is equal to mx minus x1, where y1 and x1 are the coordinates of the given point. So this y1, x1 and y1. So substitute there, we go to y minus 7 is equal to gradient, it's a -1 into x minus 0. Okay, so give us y minus 7 is equal to -x. Take it there, so therefore our y is going to be -x plus 7 to give us the equation of the straight line. Let us come over here to find the tangent. We are given that a tangent parallel to CD touches F at P. Determine the coordinates of P. Okay, 6.4. So we have a tangent that is parallel to CD. So if this tangent is parallel to CD, it means that the gradient of the tangent MT is equal to the gradient of that straight line, which means the gradient is equal to -1. So it touches F at P. Determine the coordinates of P. So just to put it here, so assuming that we have got a line, if it touches, most probably we have got the equation of the line, another the line passing through somewhere here, okay, and it touching at a point P, whose coordinates we don't know yet. So what we need to know, we know the gradient of that line. If it touches at P, we now know that the gradient of the line is equal to the derivative of f at the point of contact. So we can use that to find the value of x. So let us use it, write it as the derivative of f of x will be equal to the gradient of the tangent at the point of contact. Okay, now when we derive x, okay, the equation of x, the equation of the function is here, which is a negative x squared minus 6x plus n. When we derive that one, we will get 2 minus 2x minus 6. So the derivative is negative 2x minus 6. So this is the derivative of x. Remember that our f of x is given as negative x squared minus 6x plus 7. So the derivative of that one is negative 2 times 1, which is negative 2x to the power. We separate that end. There's a 1 times that 1, negative 6. Okay. Just to refresh on derivatives. So that is the derivative. And the derivative simply means the gradient at a point. And the point that we are referring to here is the point at which the tangent touches the curve. So the gradient at that point will be equal to the gradient of the curve. So that's the principle that we are using here. That is part of differential calculus now. So we have found the gradient of the curve is negative 1 mt. Okay, so that will be equal to the gradient of negative 1. So this will allow us to find the value of x. So negative 2x will be equal to 6 minus 1. So negative 2x is equal to 5. So our x will be equal to 5 over negative 2. So this gives us the value of x where the tangent touches the curve. So now we need to find the value of y. Remember, if we are going to find the coordinates of P, we need to find the x value and the y value. So let us find the coordinates of P where it touches. So this is the x coordinate. To find the y coordinate, we are going to substitute y will be equal to into the very same equation, negative x squared. Our x is now 5 over negative 2. So it's going to be negative 5 over 2 squared minus 6 into negative 5 over 2 plus 7 to get the y value. So let's enter that in our calculator. So we'll get negative into negative 5 over 2. And we are going to subtract 6 into, again, negative 5 over 2. And we'll add 7 is a 63 over 4, which is basically 15.75. Let's leave it like that one, 63 over 4. So y is 63 over 4. So we found the x value, we found the y value. Therefore, point P is going to be negative 5 over 2 and 64 over 4. or if you want to write it in decimals, this will be p negative 2 comma 5, and then as we have seen this one here, we said that is 15.75. 15.75. Okay, so you can write your answer as that or that. The last question is to find for which values of x will f of x minus 12 be greater than 0. For which values of x will f of x minus 12 be greater than 0? So 6.5, we are required to find for which values of the function will f of x minus 12 be greater than 0. Basically, I want to write this as f of x so that we can interpret it in a different way. So if I take this negative 12 over, I'll get f of x being greater than 12. So let's keep that in mind. So in other words, we are looking at the values of x where our function is greater than 12. Okay, where our y values are greater than 12. So when we come back to our equation here, we found that at this point, at D, these are the coordinates negative 5 and 12. Okay, those are the coordinates. So at this point, if I were to write the statement that I've just written, that f of x is greater than 12. So this is a y value. If I were to draw the line y is equal to 12, the line y is equal to 12 is the line that passes through that point D, okay, which is parallel to the x-axis. So if we look at the y values, because from here to there we have got a distance of 12, so we need to find the y values that are greater than 12 is this portion of the graph from this point up to that point. Okay, so from here, every region here, our y is greater than 12. So which means the set of values of x that define that portion of the graph is from this point, which we got already, which is equivalent to negative 5, and a point somewhere here, which we have to find out. So we need to find now what are the values where this line intersects the graph of f of x. Okay, so where do they intersect? This is the equation y is equal to x. Y is equal to 12. So what are the values there and there? We know that x is negative 5, but now we need to find the other value. So what we can simply do is to work out this one and say my f of x is greater than 12. Let's find out the coordinates where the straight line is intersecting, because we have got a straight line here, curve, and intersecting there. So this is f of x is equal to minus x squared plus minus 6x plus 7. Okay, so we need to find those coordinates there, and this is the line y is equal to 12. So I'm going to equate this to that. Okay, so that's what we'll do to find where are they going to intersect. So I'll take f of x, which is this one, negative x squared plus minus 6x plus 7, and equate it to 12. Put that one over, we've got a negative x squared minus 6x that will give me a negative 5 will be equal to 0. Change the signs. I will have x squared minus 6 applied to be a positive now. X plus 5 will be equal to 0. And when we simplify that one, factorize, I'm going to get x plus 5, x plus 1. Okay, two numbers that multiply to give me 5, they to give me that. So I will have now x will be equal to a negative 5, which is that negative 5 that we got here. Okay, and also x is equal to negative 1, which is the other point that we want, which is a negative 1. So as I said that from this is the line y is equal to, so any value above that line will define the values of y that are which are greater than 12. So to answer our question, therefore, after working this out, we can say therefore our x are values from negative 5 to negative 1. So we'll say x is element of numbers from negative 5 to negative 1. Or you can write it in inequality format as negative 5 is less than x is less than negative 1 to give you the values of x. Okay. So I hope you learned something from this section. Thank you for watching. We'll see you in the next video.